Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
This is all about packets, and here I said debug. So two-way, receive dbdx start, then exchange, then lsr, received lsu, synchronized database, and now neighborship have moved into, because just after synchronizing database your neighborship will move into full state now. Is not it good? Show IP OSPF database. The sequence number of router LSA generated by R1 is what? 2. Right? Great. If you move on R2,
age
मतलब रिफ्रेश नहीं किया रहा इसने.
No, actually we took the neighborship only between R1 and R2.
I will see it and then we'll let you know that what is the reason behind it. But ideally it's LSA refresh interval is by default 30 seconds and flush interval is 60 seconds, right? Sorry, 60 minutes, 30 minutes and 60 minutes. Fine. So this time the sequence number of a router LSA generated by R1, check it out, is 2. Hello. On all devices its sequence number will be 2. On R2, on R3, even timer edge is also same. On R5 also. Fine. Then after it, let's move back on R1. Let's check that how many times this R1 have scheduled SPF algorithm. So I do SPF. R1 have executed only one time. Let's move on R2 now. R2 have executed
13 times.
R3 R4 Hello. Now I will simply do some modification. I will do some changes on R1 only. I will shut down its loopback. Show IP OSPF database. Its sequence number is now 3. Will it be will this router, let's say, be having this links information now? Even you can open this router, let's say, on R1 itself. Show IP OSPF database router generated by 111. Does it have 111's information now? And this update have been given to all other routers with higher sequence number now. So all of them will also accept this update. If they accept this update, it means they will also remove that route from their routing table. And now, because I have shut down it over here, so its sequence number have been incremented by 1. As you can see that now, show IP OSPF database, its current sequence number is what? 3. Show IP OSPF, how many times it have executed SPF algorithm now? Previously it was 1, now it is 2. Previously on R2 it executed 13 times. And sequence number is now 3. And show IP OSPFC, this time it must be 14 times.
14.
Now let's move on R3. Show IP OSPF database, its sequence number must be 3. Show IP OSPF, previously it executed only 12 times, but this time it must be 13. Now move on R4. Show IP OSPF database, sequence number must be 3. Show IP OSPF, it must execute it as 11 times. Same on R5. It have also executed now 11 times. And sequence number will also be show IP OSPF database. See, it is also 3. And here if you open this router LSC show IP OSPF database, router generated by 11111 here, so you will see that it does not have any information about 111111.
And sequence number of other routers also are changed.
No,
They will
never. Show IP OSPF database, the sequence number of other router LSS will never get changed.
and before it used to be 3 items.
Where when it's like for an example, it was 3, but then after timer has expired, how will it be possible for others to receive this new update now after 3 minutes, after 30 minutes? So after 30 minutes also its sequence number will be incremented by 1. That's the thing. Have you understood it now? And now if you move back again on R1 and if you say no shutdown, once again it will include this loop back inside its own router LSA. Show IP OSPF database, its sequence number will become now 4. It will give this update to all others now with sequence number 4. Whenever a router will receive any updated LSA, router LSA, not any LSA, router LSA, so it has to schedule, it has to execute SPF algorithm onto its LSDB. So this is the disadvantage of running single area OSPF. Let's say that if you are having 50 routers in a single area, so of course changes will occur frequently. And if changes are occurring frequently in your network, all 50 routers will require to run SPF. All 50 routers will require to execute SPF algorithm onto their LSDB whenever there will be any change onto any router. This is the disadvantage of running only single area OSPF. So generally we do not prefer, I mean in an enterprise network, generally we do not prefer to implement single area OSPF. Generally you will configure multi-area OSPF, but if you are having let's say that you are having less number of devices, like 10 or 12 devices in the core of the network, then definitely you must configure only single area OSPF, because if you are running MPLS, then also it will be required to run single area OSPF only. Have you understood it or not? For sure. So in this way they updates to each other.
And sir, you said that if the sequence number gets finished, they will refresh.
Exactly, they will restart it from 0. Sorry, they will restart it from 1 now. They will break neighborship.
Okay. Again, they
And
will go through all the-
exactly. Understood? Great. If you want to know, if you want to ask any question, please let me know. For sure? Great.
सर अभी एक्स्ट्रा स्टेटमेंट एमक्यू के सर
Let me show you. Interface serial 1/0, IP MTU 1490, and then say clear IP OSPF process.
लेयर 3 एमक्यू होता है, लेयर 2 एमक्यू होता है.
Layer 3, sir, layer 3 1500.
हाँ, और एक उसको सिंपल एमक्यू हम लोग कमांड देते हैं वहाँ पर, इनमें क्या डिफरेंस है?
पता नहीं मेरे को भी। शायद मैंने बेसिक्स में बताया था ये आपको, लेयर 2 MTU, लेयर 3 MTU।
But DVD contains only interface MPU, right?
Layer 3 MTU. Layer 3 MTU with IP header only. Layer 2, the maximum packet size that can be accepted by interface, including layer 2 header itself. Exactly. This is the only difference in between layer 3 and layer 2 MTU.
उसके अंदर हमारा डेटा वगैरह सब कुछ
Exactly.
और इसमें सिर्फ हमारा IP है।
ये मत बोलो, ये बोलो ईथरनेट हेडर या लेयर 2 हेडर के साथ लेयर 2 MTU, उसके बिना लेयर 3 MTU। अब आ गया समझ में? लेयर 3 MTU सिर्फ IP हेडर होगा। लेयर 2 MTU किसके अकॉर्डिंगली आप डिसाइड करोगे? लेयर 2 हेडर को भी इंक्लूड कराने के बाद। सो नाउ I have changed MTU. See, on both ends. Guys, try to understand. I have changed MTU size. Here on R1 I have configured 1490, whereas on another interface, you see show IP, show interface first, sorry, serial 1 by 0. Still it is showing you 1500 because this is what? MTU. This is not your IP MTU, whereas I changed IP MTU. To change this MTU, the command will be right. So now you can see show IP OSPF neighbor. So it means that OSPF is taking IP MTU. So OSPF neighborship is not coming up now. So it performed too many retransmission for DB packets. So that's why it have moved back into down state now. Now do one thing. Now you have two options. Either configure common MTU.
Ignore MPU.
Are you getting my point? Either configure common MTU on both ends, or there is one command on interface S1 by 0 IP OSPF once you will configure this command, now your neighborship must come up. Right? What? You have to configure this command only on that side which is having lower MTU size. Yes. I got my point. If you configure this command on that end which is having higher MTU size, it will not work. Even your neighborship will not come up. So you must be remember that where to apply command. Not only command, like okay, this is the command to configure. Like for an example, if I move back again on this interface and if I say no IP OSPF ignore, and once again I will say clear IP OSPF process. It have broken its neighborship. Show IP OSPF neighbor. It does not have neighborship. It have moved into a access static state, and again I'm moving on S1 by 0. I will say IP OSPF in MTU. We'll see that neighborship will not come up now. So you must configure this command only on that end which is having lower MTU size. Remove it from here. Move back again on R1. DR other. Fine. So this is all about the router LSS now. Now I'm gonna to prove you that if we implement multi-area OSPF, are you getting my point? If we implement multi-area OSPF, then we can solve this problem of executing SPF algorithm if any change occurs in one area, right? Because there is a rule in OSPF that if you are implementing multi-area OSPF, in that case, if any change occurs in any one of the area, then SPF algorithm will be executed by all routers which are participating in that area only, in which change was occurred. But in all other areas, routers will not require to execute SPF algorithm due to occurrence of change in different area. Are you getting my point or not? So let's prove it now. So this time I'm going to do one thing here. I will implement sorry, not up to here. Here, area 0, and here I will implement area 1. Fine. So now 5. I also removed this OSPF from the database of R3. Even I will also remove it from R1 as well. So I have removed it from all routers now. Fine. Okay. All interfaces would be in area 0. This time, even the loopback of R3 output it in area 0 itself, but in area 1. Show IP OSPF interface. Done. Then all interfaces of R4 will be in area 1. Then let's do one thing, let's capture this link. And finally let's move on. Area, fine. Still it is waiting for the election of DR and PDR. Now everything is done. It's done. Right? Fine. Now the update have been given to R5 from R4. From R4 to R5. Yeah, this is the update packet given by R4 to R5. See, some router LSs are there. Is not it? Because in area 1 itself we are having two router LSs. One router LS is generated by R4 as well as R3. So it have given those two router LSs to R5, and also R3 generated some summary LSs for area 1. So all those LSs information is going from R4 to R5 now. And the router LSs generated by R3, see, flags, B bit is what? It means R3 is working as an
APR.
and this ABR's information is going within router LSA. Cool.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.